Hi everyone! Thank you for joining for part 2 of our What on Earth is the Solar System. And in this part, I will quiz Tika a little by showing her various photos and we will discuss them. Okay, so Tika, I'm gonna send you right now a photo and I want you to describe what you see.
Let's see. Oh, it says Mercury in
Yes.
very big letters. Well, this looks like a planet, a very round one. And it's like yellow patches with blue, and then there's
Yes.
tiny blue crater-like structures on it. It looks very beaten up, actually, but
Yes.
tiny craters.
Yes, and then the second photo I've just sent you.
This is I guess this is also Mercury from the
Yes.
colors.
Mm-hmm.
And then you see a big yellow spot.
Mm-hmm.
With tiny, even more blue spots on it.
Yes.
So it's
Okay.
very high contrast, I would say.
Yes. So I'm gonna now tell you what did you see. So you saw Mercury planet. And this is actually a photo from Messenger mission, so the mission which sent orbiter around Mercury.
So
between
what time was this?
2011, 2015. So these are quite modern photos of Mercury. And the colors are kind of enhanced. This is not how Mercury looks every day like. It's just enhanced for a chemical analysis. So like based on the colors, it tells you something about the chemistry of Mercury. But the features which you caught, it's actually very good because Mercury is one of the most cratered planet in the entire solar system.
Really?
And maybe you can guess why?
I mean, it's the one closest to the sun, if I remember correctly. So I
Yes,
would say it caught more of the debris right at the formation of the solar system.
that's also correct, but also it doesn't have a certain feature which is very important for stopping the craters, for like stopping
Atmosphere.
exactly for stopping the impact. So Mercury, because it's so close to the sun, it cannot hold the atmosphere, and then it causes all the debris to reach the surface, and that's why it's so impacted. And the features that I sent you as a highlight, that's the second photo, is actually close up to one of the biggest impact basins in the entire solar system, and it has a cross section of 1,550 kilometers across.
Wow.
So it's pretty massive impact. And you will see also with other planets that impactors and generally giant impacts are very popular hypothesis for formation of planets or like evolution of planets, because they can create different features we see across planets. So with Mercury formation, what scientists found that it contains quite a lot of sulfur. Then scientists thought that maybe Mercury was not created necessarily at the very beginning so close to the sun. It was actually further away. And then because of the impactor, so because of the impact, which would strip a lot of material from its surface, it also changed the day in which we see it right now. And we also this theory agrees with another observation we have about Mercury, that it has a quite massive core compared to the size of the mantle. So normally planets are a bit like onions.
True. It has layers.
It has layers, just like Shrek.
Nice.
And they found that it's virtually like ball surrounded by very thin crust, which would be also explainable by giant impact.
Can I add something theory? Because I was thinking, if it has a big core, is it the way that planets like burn up or they cool down over time? And is that why we know it's so young?
You mean like the age of the planet?
Yeah, because you said it wasn't formed right at the formation of the solar system, right?
So it was formed at the beginning of the solar system. It was maybe not necessarily formed in the same spot.
Okay.
So the distance was greater because the elements which are building solar system are varying depending on the distance. That's why we have such a stark contrast between gas giants and these rocky worlds we discuss now. So just because it has sulfur, it doesn't mean it was created later. It's just that it was created in a different place.
No, true. I was thinking the size of the core maybe meaning
so
something about its age.
So generally, it's a relative saying that it's big because it's still quite small planet. So if it would have, let's say, normal mantle and normal crust, it would still be kind of normal size planet. But just because you strip the middle layer, let's say, that's why relatively to the size of the planet, the core is big. Okay, and now moving on to second planet. Can you tell me which planet are you right now on?
So you had Mercury, and then you have Venus, right?
Yes, exactly. So I've sent you another yet beautiful photo of Venus. Can you tell me what you see?
Oh, this is this looks fun. It's very orange yellowish color. And I think it's a picture of the surface.
Yes.
More close to the surface because I see like mountainy structures.
Yes.
But then I also see these lighter stripes on it. It's like stretch marks.
Mm-hmm.
And it looks very fluid. Like it waved somewhere.
Does it resemble anything we see on Earth?
I would say it should. There is some geomorphological structure there. I'm just not sure which one at this point.
That's okay. That's okay. We're gonna get into it. So yes, this is Venus surface, and this is actually computer-generated 3D model of Venus surface, which shows the volcano. It's called Sif Mons. Sorry for my pronunciation if I said it wrong, but this is how it's spelled. And it shows signs of ongoing activity. So that's why I asked, like, if there's resemble anything we see on Earth. It kind of looks like current, like lava flows. So you see the stretch marks, and this could be like, the ripples of magma. Really, really interesting. And this planet is very similar in size to our planet. That's why it's often called the sister planet.
It's also way hotter than Earth, right?
Oh, yes. Actually, it's so hot that it's like 735 Kelvin, which is even hotter than Mercury. And Mercury, is much closer to the sun. And only, Mercury gets only like 420 Celsius degree. I think that was the correct temperature. So this is like way, way hotter. And do you know why it gets hotter, even though it's further away?
Well, what I remember from college is that Venus had a very thick atmosphere of methane, I would say, and then therefore a very high greenhouse effect, right?
Yes, correctly. So it's not methane, but it's a dense CO2 atmosphere. And the pressure, because of this very dense atmosphere, is insane. It's like 94 times the pressure of Earth's surface.
It's almost like a PhD.
Formed under pressure. It also has nitrogen in relative few percentages, so it's not that present there. But also quite important feature of Venus is that it spins the other way around. So when the sun rises on the west and it sets on the east. And do you know why?
We know why. Giant impact, right?
Giant impact is one of the hypotheses why it spins the other way around. So this would be Venus. And let's move on to very easy planet for you to recognize when I'm gonna send you a photo. So that's why I'm gonna send you a photo of something else. Can you tell me what you see?
Yeah, so I know the next planet, but now I'm confused. I thought the next planet was Earth.
Yes.
But this doesn't look like Earth. It looks more
like the moon. Does it look like Earth? Yes, because it is moon.
Yeah. I'm so happy with my own skills.
See, it is the moon. It is the moon. It's our own Earth's moon. Because I was like, okay, if I'm sending you a photo of Earth, where is the fun in that? You cannot know it.
My fear of failure just came out like very strongly. Because this is not Earth at all.
I threw you a curveball, you know.
Yeah, you threw me the moon.
I threw you the moon. So I actually thought I'm gonna send you this photo because it's our first moon, and our moon is pretty interesting. Not only because I did my PhD on it, but it's relatively large compared to the size of our Earth. So the moon's mass is about 1.2% of Earth's mass, which means that it's like 81 times less massive than the Earth. Which for planetary standards, it's a relatively big moon, because you will see that Jupiter's and Saturn's will have many moons, and they are quite big as well. But we will probably have a separate episode about our moon. So for now, I just wanted to start with the small fact that, yeah, we do have our natural satellite. And our planet is the only planet in the solar system that we know we have life. And this also has an impact on a lot of things. Our planet is very geologically active. We have plate tectonics. Plate tectonics meaning that we have plates which are moving atop of mantle. And then we have a core which is liquid and the inner core which is solid. And all of this constitutes also that we have a very strong magnetic field. And the fact that we have a life, it also gives a lot of oxygen to our atmosphere, right? We have a very thick atmosphere made of mostly of nitrogen, 78% of nitrogen, 21% of oxygen, and the rest, I think, it's argon. And of course, the atmosphere evolved through time, which Tika, you will know much more about than I do. And I'm happy to listen about it in the next episode. And generally, our planet is unique. We have liquid water, we have water, ice, but we also have a vapor. All of these things makes our planet extremely unique for the solar system.
And also, this whole podcast is about Earth, right? So we'll have plenty of time to talk about it.
Exactly. So I'm just gonna finish here and we move on to another planet, which I'm just sending you photo. This is gonna be very interesting part. So I've sent you plenty of photos, Tika. How many do you have?
I have 4.
4. Can you start with the second? Because why not to start with fast? It's gonna be too easy.
Well, you said we were going to talk about Mars, and what I remember is that it's supposed to be red. It does not look red. It looks more yellow with blue stripes on it, and well, stripes is a bit much, but it has blue spots as well. Ooh. And in the middle of the picture, there's this blue fanning structure that looks like what I know from water.
Yes, precisely. So what you see right now is the photo of not a close-up photo, it's actually whole planet photo. And in the middle, what you see, it's a canyon. It's called Valles Marineris, and it's 5,000 kilometer long and 10 kilometers deep canyon. It's one of the largest canyons in the solar system. And if you, it would literally stretch from one coast to another of US. It's that large. And yes, you correctly notice it's not necessarily red. It has a red hue. I think it's just a filter because normally it's pretty red. And the blue spots, I think just you see right now here are just mountains. So actually volcanic mountains. We're gonna lead to it because now if you can tell me what you see on the first photo.
The first photo, that looks like a close-up of a crater impact with more craters in between, in the middle.
Yes, although it's not a crater because it has a positive relief, so it's actually up, not down.
Yeah.
So it's a volcanic mountain, Mount Olympus, which is the highest mountain in the entire solar system. It's 3 times bigger than Mount Everest, and it has 25 kilometers height. I would climb I would climb that.
That's insane.
It is. So right now we know that Mars is not only hosting one of the biggest canyons in the solar system and also one like the tallest mountain in the entire solar system.
I mean, I now know why we want to go there.
It sounds pretty cool.
Yeah, it sounds
Also,
pretty cool.
not only that, it also has a bit more atmosphere. It's not, nowhere near comparable to Earth atmosphere. It's about 1% of the Earth's thickness. It's mostly CO2, and it has a few percent of nitrogen, molecular nitrogen and argon. And because of this atmosphere, it also has weather. So like winds and some small devil winds, like those twisters. And I think this is not a news for people who watch The Martian, because we had to rescue Matt Damon because of that.
Oh no.
I don't know. Have you seen The Martian?
No, we should.
You definitely should. Maybe we should watch it and review it on the podcast. That could be interesting. Okay, but can you tell me now what you see on the third photo? It's a bit trickier.
Oh, this is a weird shape.
Mm-hmm.
It's not round. It's more like a geoid kind of shape. So geoid is not round, but roundish.
Yes.
It has a lot of bumps and lumps on it.
Yes.
But it also has some kind of stripe structure.
Yes. Exactly.
And I'm guessing this is a moon?
Ding, 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 ding.
Yes! I'm getting good at this.
Look at you. Mars has two moons, so two natural satellites, Phobos and Deimos. And this one that you're right now looking at is Phobos, and it's very interesting because it orbits Mars on the orbit of like 6,000 kilometers away from the surface.
That's super close, right?
Super close. This is the closest moon to the surface in the solar system. And the lump that you see on the right side of the photo, it's again giant impact crater. And those stretch marks are actually stretch marks from gravity, where Mars is pulling the moon towards its surface. It could also be explained by like rolling boulders around it, when after impact you start rolling stuff around. But it could be explained by the by stretch marks of gravity. And because of
if you say it's gravity, does it is the distance to Mars getting smaller?
Exactly. It is. It does. 2 centimeters per year, which might not, sound exciting, but I would say you don't want to be on Mars in like 30 to 50 million years, because this moon is done for. It's gonna hit the surface. Well, it either will hit the surface or it will be destroyed by gravity, shreds to pieces, and Mars will have beautiful ring system. So let's find out in 30 to 50 million years what's gonna happen.
Really cool.
Okay, and the last photo, can you tell me what you see here? I saved the best for the last.
Oh, this looks like a rocky close-up. I'm not sure about the scale though, because this can be like centimeters, but it can also be like the surface of a planet. And I'm guessing
it's centimeters. It's a close-up.
Okay, so it looks like, yeah, it has layers. So we have a more resistant layer on the right side and the left side, and in between a more grainy layer. And the more resistant layers also have lumps, it looks like.
Yes.
But not very more amorphous lumps.
Yes. And can you tell me what is a quite capturing feature in the middle strip? Do you see anything?
Yeah. How do you describe it? It's like grains.
Yeah, it's like white patches.
White patches with like greenish black colors around it.
Exactly. So what you see right now is something which was baffling scientists for a year. because this is a photo captured by NASA rover Perseverance. And it actually went to the bed of a very ancient river, because yes, we think on Mars we had water in the past. More because like the morphology of the remnants looks like this, so we have like flow structures and stuff like that. But also we have ice on the on the North and the South Pole.
Ice, baby.
Ice, baby. So there are evidences that Mars was much more geologically interesting because it had fluid water. But what you see here right now, really recently, like a month and so ago, NASA held a press conference and they said that this what you see, this like white patches with black rim, could be evidences of ancient microbes.
So life on Mars.
Just like Bowie said.
He was right all along.
So that could be the very first signs of extraterrestrial life. So this clarification, we don't think these are microbes. We think that these are rocks which have signs of microbial life in it. Because like Tika, you know probably that some microbial life can change the structure of the rock, right?
Yes.
Yeah. So this is explained by just exactly that, although you can produce these by different processes like constant high temperature, acidic conditions, or binding organic compounds. But none of these are something which was found in that spot by the rover. So this is really exciting news. Like when I saw this news, I was actually on my way to work and I was like listening to it. I was like, God, that's amazing. It's like Random Tuesday, and those NASA scientists just found tiny alien life. That's pretty cool.
That's really cool. It was September 2025, right?
Yes, September
because
2025.
We're recording October 2025, and this episode will air sometime later. Maybe we'll know more by then. Well, maybe we know more when this episode airs, and we'll have to elaborate on it.
Yeah. So that will be about Mars. I think it's a perfect moment to take a break because we'll be transitioning from the rocky worlds into the gas giants. And I would like to invite you for part 3, the last part of our planetary series. So please like, subscribe, leave a comment, and join us on Instagram or Facebook to let us know if you actually liked it. I hope you did. And we will meet you next week for our last part of the planetary series. So see you next week. Bye.
Thank you for listening. See you next time.